the squeeze theorem stuff, and I'm going to do that later.
Okay.
So that is your first page. That's your first 4 slides. There. So skip over to the one that says, second page where it says special trig limits.
That's on the back of the first.
Back of the first page. Okay. So these 2 special trig limits right here in the boxes you need to know. Okay, so they have to be memorized. You just have to know them. When I go over squeeze theorem, I'll show you why this is true. But for right now, just take my word for it. If you have the limit as x approaches 0 of sine x over x, it always equals 1. If you have the limit as x approaches 0 of 1 minus cosine x over x, it always equals 0. Whenever you're plugging in a number, yes. Like if you had sine of 30 or sine of pi over 2, they are values that you could replace. But when we have an x, it's more like an operation. Like taking the log of something. Like sine of something is kind of like taking the log of something.
Do we have to know like tan equals sine over cosine?
Okay. Alright, let's look at this first problem. What we're going to be doing here is basically, what we're going to be doing here is we basically, with these trig problems, we want to get all of these broken down to where we either have this limit or this limit or something we can plug a number into and use direct substitution. If I do the limit as x approaches 0 of sine x over x and try to do direct substitution, I've got sine 0. Oh, this is so aggravating. Okay. 0 over 0. There. So what is sine of 0? It is 0 over 0. So this is indeterminate form. You can't solve it by direct substitution. But I'm telling you, it equals 1. Right, so
I believe it. I don't.
Yeah, just believe me right now. I could suggest some YouTube videos proving it if you really like. But otherwise, just believe me. Okay, so this always equals 1. So if you look right here on this first example that we have, we've got sine x over x right here. So what I want us to think about doing, is it okay for me to write it like this? Is that equivalent to sine x over 7x? Because if I were multiplying fractions, I could just multiply the top, multiply the bottom. It would give me sine x over 7x, right? Now, 1/7 is just a coefficient, right? So our limit properties tell us that we could just pull this out front. We could write it like this: 1/7 times the limit as x approaches 0 of sine x over x. And then this stuff right here, I told you up here that it always equals 1. So I got 1/7 times 1, which is 1/7. X must be approaching 0. It cannot be approaching any other value for this to be true. So what we know right here, this limit as x approaches 0 of sine x over x, it's a fact that we know and are going to memorize that it always equals 1. So we can replace it with 1. Yeah, the whole thing. Yes. These are usually going to be multiple choice, so it doesn't matter if you show the work or not, but yes. Right, you can't just drop the limit. that would be, like, although it'd give you the same answer, it would be theoretically wrong, and if you had some sort of, like, other problem, maybe it might not work. Yes. 6. Half of the test is, yes, half is multiple choice. As far as your grade goes, half is multiple choice, half is free response. Yeah, as far as the points for each section. Yeah, you're not going to be able to guess as well on those multiple choice. They're not easy either, but they're a little easier than the free response. Only 4. There used to be 5, but now there's only 4. But I'm going to teach you how to do all of them, so you're not going to have to guess. All right? Okay, all right, example 5. Now, we can't get anywhere with tangent, because tangent is not in either one of our special limits that we're going to memorize. But tangent is sine over cosine. So those trig identities that we did, they're coming back. So we got to remember that tangent x is sine x over cosine x. That is a fact that we need to make sure that we know, right? So I can do this, the limit as x approaches 0 of sine x over cosine x over x. Okay. Dividing fractions is easy as pie. Flip the second and multiply. You could skip that step if you would like, yeah. So I'm going to write it like this. Okay, this looks a little better than what we had. Do you see here the sine x over x? Okay, so let's think about what we did on the last problem. We broke it up into 1/7 times sine over x. That was equivalent, right? So I can do the limit as x approaches 0 of sine x over x times 1 over cosine x. And I'm going to write this step. I usually would not write this step if I was doing this problem, but to be very clear about what's happening here. Properties of limits tell me that I can take the limit of these two things that are multiplied together. I can take the limit of them separately and then just multiply what I've got. So you don't necessarily have to write this. You can do this part in your head. But you can do the limit as x approaches 0 of sine x over x times the limit as x approaches 0 of 1 over cosine x. And we know, what does this right here equal? That equals 1. That's a fact that we're memorizing. What would we do for that second part? I mean, it does equal secant, but it's not really going to help us that much. Don't have to do conjugate. All right. I'm going to plug in 0. What is cosine of 0? Is not 0. On that unit circle, that's right here. Coordinates are 1, 0. X coordinate is your cosine, right? It's 1. And that's okay to have, right? So you're not getting 0 over 0 or even undefined right here. So get 1. Yeah. So we just did direct substitution right here. and you're seeing here, it's usually not going to be like 5 pi over 3, but you're going to have to know your unit circle values in order to do this. Yes?
So what was the point of direct substitution over there? Like, why didn't you just know it's 1 times
So you're looking at this as the limit as x approaches 0. So you can't just make it 1 over cosine x, because we're looking at that limit. So you've got to plug in 0 for your
you just have to show that there's a limit without the 2.
Yeah, because really what you're doing, if I wanted to, I could put some brackets right here. You're doing the limit of this whole thing, not just the first part. So you have to do the limit of these two separately.
Will they make you show that?
If you don't show this step, that's fine, but you would not want to do just like this first limit and then have 1 over cosine x. That would not be good. You would need to skip down to this line where you've already plugged the 0 in. Does that make sense? Yes. It is page 85, and which you probably already have a picture of, and let me see if it goes on. It may just all be on 85. Yeah, it's all going to be on 85. Okay. Good luck. Okay. Here is our next one. We're done on 2. Of course there's. You don't really know how to do this one. Yeah, I wouldn't try it. Okay. So, we've almost got sine x over x, but we have this 4 right here that's giving us trouble. You cannot just take it out. Although, you're going to get the same answer, now, something to know is that the limit as x approaches 0 of sine x over x is going to still be true as long as these two pieces right here match. So if I had the limit as x approaches 0 of sine of 4x over 4x, that would still equal 1. Or if I had the limit as x approaches 0 of sine of x minus 2 over x minus 2, that would still, I think it would still equal 1, I believe. If these two match, it equals, I know it is with the multiplication. Because you could do substitution. That actually, maybe it has to be multiplication. I should probably think that through a little bit more before I use that example. But what we need to know is that if you have the 4x on top and bottom, then this is going to equal 1. So, any ideas? Okay, so Jack says that I should multiply by 4 on top and bottom. Can I do that? Yes. Can I do what Jack just said?
I feel like you can do that, but I feel like it's
You can. And then, this is just a coefficient, and it can go outside, right? No.
Good job, Adam. Thanks for that. I asked you to factor in later. No, I said no. I know. That's correct. Yeah, you literally heard me wrong. No, what we said.
All right. Shh. Okay. So this part right here equals 1. 4 times 1 equals 4. Now, Now, I will admit, if you had a problem like this, let's say we had a 6x, if you incorrectly just pulled the 6 out, like that, and did it this way, it technically is going to give the same answer. But it's incorrect thinking. I would do it just like I've done it here. Yeah, don't. This is incorrect. You cannot pull a 6 out. However, if you do it incorrectly, it does still give you the right answer on these. Yes, you can do it. You can do it like this right here. So what you would need to do is you would do the limit as x approaches 0 of 6 sine 6x over 6x. You put that 6 on top and bottom. Yeah, and then you could pull the 6 out. So it'd be 6 times 1 there whenever you do that. Right, it's not the right way of thinking to pull that 6 out, even though it does give you the same answer. You need to multiply top and bottom. Okay. All right, okay, here we go. Secant. Secant, what does it equal? 1 over cosine of x. So that's a fact that we need to remember from pre-cal. So we definitely can't do anything with this while it's secant. So we got 1 over cosine x minus 1 over x. All right, I'm going to show you a different way of solving this besides common denominators. Just to see if you like it better. No, this is correct so far. I'm going to just do, so you can get common denominators, flip, and multiply. Because I've only got a single denominator here, here's another method you could use if you would like. Okay? I'm going to multiply the top of this fraction by cosine x and the bottom of this fraction by cosine x. Is that okay to do? As long as you're doing top and bottom, it's okay, right? So when I distribute, what is cosine x times 1 over cosine x? Cosine x times 1 over cosine x. Right? Cosine x's would cancel. It would just be 1. And then I'm going to do cosine x times the negative 1, which is going to give me minus cosine x. Over, I'm going to write the x first, x times cosine x. I like doing it this way whenever you've only got one denominator because you don't have to do the flip and multiply part. But if you do common denominators, flip and multiply, like we were doing like number 62 and 61 back there, it'll get you the same answer. Technically, you can do the same thing with that, but you'd have to multiply by 4 and x plus 4 if you do it. I need limit notation. Because when we distribute right here, we're doing cosine x times 1 over cosine x, which is what I did right here. And the cosines will cancel, just leaving that 1 from the numerator. And then I will do cosine x times the negative 1. So cosine x times negative 1 is going to give you negative cosine x. Okay. All right, now if we look, we should be seeing one of those special limits here, because here we've got 1 minus cosine x over x. So, like we've done with the other problems, we can do the limit as x approaches 0 of 1 minus cosine x over x times 1 over cosine x. And then we can take the limit of each one of these separately, which I'm going to write it just for, if you don't write this step, it's okay. So this special limit right here equals 0. Over here, I would do 1 over cosine of 0. It really doesn't matter what that is much because you're multiplying it by 0 as long as it's not undefined. And it's not because cosine of 0 is 1. 0 times 1 is 0. Even more disappointing than doing that other problem just to get 1. No, because we're not going right.
Wait, why does 1 over
Cosine 0, if you look at unit circle, equals 1. Yeah. We just plug 0 into the limit here, just direct substitution. All right. There's several ways you can do this problem. It is sine squared x. So remember, we know sine squared x plus cosine squared x equals 1. So if you move a cosine over sine squared x is going to equal 1 minus cosine squared x. It'd also be true that cosine squared x equals 1 minus sine squared x. So, what could I do? Could replace it here, right? Sine squared x over x. Okay? So, if sine squared x means sine x times sine x over x, and right here is my special limit, right? So, we can do the limit of these separately. And so, this part right here is just 1. And then I'll use direct substitution here. I'll get sine of 0. What is sine of 0 from the unit circle? It's your y coordinate, 0.
That step that has a box on it, and you have 2 limits, we have to write it.
I can live with it if you don't. I can live with it if you skip from right here down to here. If you do the limits separately in your head. I won't be a big stickler on work for this.
You said these are going to be like multiple choice.
These are they'll be on the multiple choice section of the exam, of the final exam. On the quiz we're going to take on Friday, they're going to be typing your answers. Yeah. Which I will tell you, if it is a trig one and you have no clue what to do, 0 or 1 is a good guess. And I'd pick one of those. Yeah, I know. 0, I don't like it whenever I get 0. It's a little disappointing. We're going to skip number 9. Let's go to... Oh. Okay. We're going to do these last two fast. Okay. So, if I plug in 0, e to the 0 minus 1 over 1 minus e to the negative 0 is going to be 1 minus 1 over 1 minus 1, which is 0 over 0. I'm plugging it in. I'm direct substitution.
Hold up.
It's the first step.
That's why we gotta do what we gotta do.
So, alright. Alright, all I'm doing is plugging in 0 to see if direct substitution works. Negative 0 is just 0. And anything to the 0 power is 1. And you get 0 over 0, which tells you you've done nothing here. Right? So we gotta try something else. How else could I write e to the negative x? 1 over e to the x. Negative exponents go to the bottom of a fraction. So I could write it this way. Alright. I don't like having fractions inside of fractions. I'm going to do the same thing I did before, where I've got this denominator. I'm going to multiply the top of this fraction by e to the x and the bottom of the fraction by e to the x. I want something to cancel here, so I'm actually not going to multiply the numerator together. I'm going to leave it as e to the x times e to the x minus 1. And in the denominator, I am going to distribute because I want to get rid of that fraction. So when I do that, e to the x times 1 is e to the x. And then what is e to the x times 1 over e to the x? E to the x's cancel, and you just got minus 1. Now what can happen? Cancel these. Direct substitution. E to the 0 equals, no, 1. Anything to the 0 power is 1. Alright, one last one. I know I'm going fast. I gotta go. Okay. Alright. Think of it this way. Think of this as 2x squared plus 3x minus 5. You know how to factor that, right? Okay. So, this e to the 2x, I'm going to factor. So, I have 2e to the x times e to the x. Okay? Then I've got a negative 5. I need to get a positive 3 in the middle. So what could I do? Positive 5, negative 1. Is that going to work? Okay. 2 times the negative 1 will give you a negative 2. This will give you 5. E to the x minus 1. What can happen? These cancel. I should keep my limit notation and not be so lazy. Now I can do direct substitution. 2 times e to the 0 plus 5. 2 times 1 plus 5. So 7.
See, like, I get it when I get
The factoring is what's
You might want to work on that. Okay. The assignments, do not do 97 through 102 because that's squeeze theorem and I skipped those examples. So do not do 97 through 102. Let me see, there might be one more I need to throw out. Let me look real quick. Yes. Let me see if there is one I want to throw out. What numbers did I say? 82. Make that 80 instead of 82. So do page 85, 69 through 80 instead of 82. all of them. It's all of them. All.
We already have the answers. I think wait till like count check.
The answers are there so you can check to make sure you did it correctly. The only well, you need to show work. If you show up with just numbers for all the odd ones, Daniel, you're not getting credit. Yes, if you did not have all your work today, you can bring it to me tomorrow with a late work pass and you'll still get full credit. Or you can get half credit for the part you didn't do. If you choose, because that might actually be better, taking a 3 out of 4 so you can hold on to your late work pass. Yes, it's only 85.
I'm just taking the whole